Thank you for coming into this late session. My name is Alexander Chatzizacharias. A little bit of a tricky last name. Well, unless you're Greek. I don't know if anybody here is Greek, then you can pronounce it quite easily. I have a couple of hobbies. I play, well, I boulder, but I also have a way too expensive Magic the Gathering collection. But my biggest hobby is gaming. I have also a little bit of a gaming background. I don't know if there are other gamers sitting here. Proud gamers unite, right? I work at a company called J-Driven here in Nieuwegein. It's a small consultancy, 30 people or something, and we are just spread all over the Netherlands consulting on, well, I would say the standard companies in the Netherlands, Rijkswaterstaat, Bol.com, you know, stuff like that, Port of Rotterdam. And that's where I'm right now for RootScanner. I work for RootScanner.com, which is a subsidiary of the Port of Rotterdam. All right, so that's about me. So this talk, the goal of this talk is like, you know, 1.5 years ago, D-Day happened. ChatGPT was released to the public and everybody went nuts. I was one of them. And then I was thinking, okay, this is pretty cool. Can I make it myself? Well, I found out pretty quickly that it would cost me a couple millions, which I did not have, unfortunately. So then I kept digging around, looking, okay, how does this technology work? What is it? What do I need to, you know, get started? And then there was one term that kept coming back, and that was vector databases. If you have a little bit of background in gaming, or you know how gaming development works, vectors are something that are very heavily used in gaming, mostly as positional systems, so that intrigued me immediately. So started diving into vector databases, made some demos, tried to figure out how they worked, how could they be so fast in finding the correct vectors, and I'm going to show you a little bit what I did and hopefully inspire you to use them for your own use case. All right. Before we start talking about vector databases, there's one very important part that everybody needs to understand, and those are vectors. Are there any mathematicians sitting here? Oh, great, I can say whatever I want. Okay, so mathematically speaking, this is a vector. If you Google it or Wikipedia it, this is pretty much what you see. You see a number, a letter with a arrow on top of it. And vectors are actually mathematical constructs that are very good in representing a distance and a direction. They are very good at encoding that. But more generally speaking, vectors are actually very good in just encoding data. If you look up vectors, you'll quickly find out that they have a dimensionality. This is a vector with 2 dimensions. This is a vector with 3 dimensions. And this is a vector with 8 dimensions. Well, I'll just assume most of you here are software engineers. If you see this, there's probably one thing you immediately think about. Hey, this is just a list of numbers, right? So, yes, actually you can think exactly like that. A vector dimensionality is actually an array of a list of numbers, and the dimensionality is the size of that array. So if you hear, okay, my vector has 1,024 dimensions, then you can think, okay, it's just a list of 1,024 numbers. So what do we do with these vectors? Well, some 13 years ago, 10 to 13 years ago, researchers started translating or transforming text into what we call now its vector representation. So they grabbed a piece of text, and we got a vector representation out of that piece of text. And after text, well, the first thing that followed were images. So there was a way they developed ways to vectorize images. And now we are in a state where everybody and everything are trying to vectorize all kinds of things. So think audio, 3D models, point clouds, you name it. So we are like in this gold rush age where vectors are maybe one of the most important data points or data format we have. Well, how do they do that? Through machine learning. I assume everybody has heard of machine learning by now. Maybe you played with it in the past. But basically they use so-called vectorization techniques or embedding models. So OpenAI has an embedding endpoint. What that endpoint does for you is you send some data to it, text, image, you name it, and it will give you back the vector representation of that text. And that is done through so-called embedding models. So there's a machine learning trained models that understand the text, the context, and give you back a vector representation. There are a lot of vectorization techniques out there. The first one was Word2Vec, released in 2013 by Google, and Glove a couple of years later. These two had a really big flaw, and that flaw was they didn't understand context. So a word with different meanings in different contexts would still have the same vector embedding. Until a couple of years ago, where transformer models were released, and these models actually understood context. So words with the same meaning in different contexts would have a different embedding. And that really allowed large language models to take off, to actually be able to give you context-aware semantic responses. All right, so those are vectors in very short. Now let's talk about databases. Everybody knows what a database is, right? I'll just assume yes. But what is a vector database? It is really a purpose-built database. It has one purpose and one purpose only. I tried using it for other purposes. It's not a good idea. And that purpose is to store and index high-dimensional vectors. Don't use it as a time series. Don't use it as an event sourcing database or something like that. Maybe you can use the document store, but really their purpose is store vectors and retrieve those vectors. And the retrieval happens using nearest neighbor search algorithms most of the time. And of course, you can store all kinds of associated metadata with the vector objects. So you can think of, well, if you think a relational database, you have a table. Normally, you have an ID that is the key. Well, the key in this case is your vector embedding. If some tech illiterate project manager comes at you and asks, okay, everybody's talking about vector databases, so we should use one, right? This is the answer I've given in the past, and they seemed pretty content with it. It's a database that facilitates effortless and swift semantic search on your data. And there is a keyword here, which is semantic, right? If you just want search on your data, you would use Elastic or maybe your own implementation. But if you want semantic search, so like context-aware search on your own data, then you probably are looking at a vector database as your store. Right now, vector databases are quickly, put together with AI because large language models use them underwater. All kinds of retrieval augmented generated applications also use vector database underwater. But the vector database by themselves have nothing to do with artificial intelligence, actually. They have no built-in machine learning models or anything like that. They're just very specialized databases that are very good at storing a vector and retrieving those vectors, those numbers. So that means that if you can put in any number you want in there, it doesn't have to be a vector embedding of anything. So for example, I tried to recreate a Minecraft world using a vector database. It didn't work out very well, but it's possible. So indexing in vector databases happens using all kinds of algorithms. You have, for example, linear search. And if you know algorithms well, you see linear search and you think, okay, that doesn't scale very well. It's true, it doesn't scale very well. K-nearest neighbors is a popular one. Shout out to Spotify for approximate nearest neighbors, oh yeah. And my personal favorite is hierarchical navigable small worlds. I never expected to have a favorite algorithm, but I guess here we are. And all these indexing algorithms use so-called a distance metric. And it's a metric it uses to calculate the distance between vectors. So it can be Euclidean distance, that is basically meters, centimeters is the most standard one, or similarity, cosine distance of similarity, and some other things that are pretty popular. You might have heard of them or might have not. They're not super important, but they can actually have an effect on how good your data is retrieved out of the database. So if you play with a vector database and you're like, okay, I'm not getting the data out that I need to do, expect to get out, you can play with distance metrics. All right, Very important thing to understand is that distance calculations and indexing in a vector database happen within the same vector space, so to say. So you can define this vector space by schema or by table, by object, or by many, many more. Every database vendor has its own way of defining the vector space. But the most important thing to understand about vector spaces is that they enforce you to always have the same dimensionality within the same vector space, so that you would never check a vector with 512 dimensions against a vector with 384 dimensions. Mathematically speaking, it's possible, but you would really get weird results out of the database. So we just don't do that. So it really enforces you to have the same dimensionality checked against each other. Now, I am a little bit of a game nerd. So if I hear vector space, I'm like, okay, that sounds cool. So let's recreate that. So what you see here is actually one of the data points in the database, which in this case has the label longbow. And if you fly around, you'll see more data points. Now, I will be the first to say that this is not necessarily the most user-friendly way to look at your data. But it's definitely the most fun way to look at your data. But what it's really all about, so these are all the planets or the data points in the database right now. And what you see is there are clusters being formed. And those clusters is exactly what you want in a database. So this is, for example, an Jorge. I don't even know what that is by now. Or an Astra, a little bit spoiler from what's coming, or a Glock. So these are all similar objects that have, semantically speaking, a similar meaning. So they end up pretty close to each other in the database, distance-wise. So when you search for something that is, semantically speaking, close to this object, it would end up close to one of these objects. But we'll see that in a bit. Right now, there are a lot of vector databases out there. I think these are the biggest vendors right now. There's really a gold rush for vector. Everyone and everything are trying to release a vector database or have at least vector support. For example, Postgres has a PG vector plugin that you can use. Even Neo4j, a graph database, has a way to vectorize your graph nodes, which is really weird, but I guess somebody thought it was a good idea. What's maybe very interesting for you is everything on your right side is open source, everything on the left side is closed source. Pinecone and Redis, well, the vector database is part of Redis Stack, which is the closed source part of Redis, not the open source part. Elastic, they did that shenanigans with their license a couple months ago or a year ago or something like that, where they're open, but not really. So I'm not really sure, actually. But Chrome, Amilus, VB8, those are all 100% open source. What's also really interesting to know is some databases offer built-in embeddings. That means that you don't need to do external calls to get your embeddings of your data, so that you can just put your data in the database or commit your data to the database, and it will embed that data for you into its vector representation. If a database doesn't support that, then you have to do a call to OpenAI or Hugging Face, get your vector embeddings, and then put the embeddings in the vector database yourself. Of course, some of them all of them need to earn money, and of course they do that by offering managed services. Almost all of them have that. PG Vector you can get through Supabase, which is also quite popular managed service out there. And if you want to do calls, well, one thing is for sure, Python is king in AI land. So all of these databases have Python clients. A lot of them you can call through a REST API. Some also have JavaScript clients or CLIs. Some of them you can call through good old SQL. And Vespa you can query using YQL. Does anybody know YQL? I believe it stands for Yahoo Querying Language, which is a choice. All right, so that's a little bit of an introduction to the landscape. So let's go into implementing our own search. So our stack is we're going to be using VB8 as persistence. For backend, we have a Kotlin Spring Boot application. I know, Kotlin, this is the GVM, right? Well, unfortunately, all the database vendors do not offer official .NET clients, but they all do offer official Java clients. So that is something interesting, I guess. It does say something about the ecosystem, right? So yeah, we're using Spring Boot application Kotlin, and in case you ever want to work with a GVM, use Kotlin. Never use Java, guys, really. It's so much better. And front end, we'll be using Unity. Anybody knows Unity? Right, the game engine is, yeah. Anybody used Unity before? Great. It's a little bit of a bad boy right now, huh? After what they did half a year ago with their pricing schemes and everything, and the enshittification of their platform. But yeah, I mean, it's still one of the things I'm most proficient in, so I decided to just write with it. So why did I use Weaviate? Well, it's open source, so that was quite nice. It's completely modular, so I could run different embedding containers next to the database and try different things out quite easily. The documentation is quite decent, and the Java client is actually also pretty decent. Their .NET client is non-existent, so. And I can run everything offline, which is quite nice if you're standing in a conference where the Wi-Fi sometimes is lacking. All right. When it comes to architecture, it's actually pretty simple. Through the backend, we'll do REST calls to the front end, and then it will do GraphQL REST calls to the Docker container of Weaviate to get our data in and out. Are there any architects here? A couple. So I've had the question, why not just directly go from the front end to the Docker container? Weaviate is just REST calls. To that, I have a very good answer. I'm a backend developer, and if I see a chance to add abstraction layers where they're not needed, I am going to do that. So that is what I did here as well. Okay, so for today, we'll be using cosine distance as distance metrics, hierarchical navigable small worlds, also indexing algorithms, and then some BERT, ResNet, and CLIP models for our vectorization. How that looks, you'll see in a little bit. Cosine distance, math. What's really important here is if the distance is 0, that means two vectors are identical, and if the distance is 2.0, that means two vectors are opposite to each other. So, for example, if you grab let's say, a Java class and a C# class, and you throw them in, there's a chance that they, might end up quite close to each other because they are similar languages. But you grab a C# class and a JavaScript script, well, hopefully they won't be very close to each other, unless you did some really funky things with your C# class. All right. Hierarchical navigable small worlds are a little bit trickier to explain. So I tried to do it like this. So let's say we have, these are all the data points we want to enter in our database. So we're just going to start with the first one. Well, what happens is that every time a data point is entered in the database, it's going to do a proximity search around it, and it's going to build an adjacency graph, or neighbor graph, or friendship graph. It has 20,000 different names because we're so good at naming things in our industry. But yeah, basically, in our case, it will be build a neighbor graph of 3 neighbors. And it's gonna do that for every single data point that you enter in, or object that you enter in your database. Now, after there's a random chance. In our case, it's around 60%, I believe, that a data point is going to be duplicated in a higher layer. And it's 100% duplicated, so it's nothing like that. You can tweak it, of course, but it's going to be duplicated. Random chance it's going to duplicate it in a higher layer. And then again, there is even lower chance, roughly 30%, that a data point in the second layer is going to be duplicated again in the third layer. Now, what happens if you do a search? Let's say you do a search and the search vector ends up here. So this is the vector you're searching for, right? The entry point, the search entry point is always the same on the topmost layer, and from there we're going to go to the object that is closest to our destination. And when we find it in the topmost layer, we're going to use that as an entry point in the lower layer. Again, we're going to go to the closest object and use that again as an entry point to go to the close to the closest node where we're searching for. And as you can see, the bottom layer is extremely dense, while the top layer is quite sparse. So like that, these databases really allow you to search through millions and millions of vectors quite quickly. So let's add all our data points again, and this time we end up here somewhere. Yeah, and again, same entry point. We go to the node that is closest to our destination, then use that as an entry point, and like that we can skip so many steps and checks and etc. 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 And the hierarchical navigable small world is really an evolution of skip lists, actually, if you ever use them in your work. All right. Does anybody recognize which movie I'm referring to here? The Matrix, thank you very much. Yes, very cool movie, cult classic, I would say. There's a scene where Neo is asking for guns, a lot of guns, and then they give him the guns, but there is a huge plot hole here. How is he ever going to find the gun he's searching for? So we're going to help Neo a little bit. I have a simple CSV file with 3 properties in them. The name of the weapon, the type of the weapon, and the range of the weapon. So for example, Excalibur, sword, and the range is short. So it's what's actually happening underwater when you have a data set like that. When you embed it, or when you tell Weaviate, okay, embed these properties for me, what it's going to do is it's going to join them into one single string, in this case, weapon, Excalibur, short, sword. It's going to lowercase it, and it's going to put it in the database. It's going to create the vector embedding and put it in the database. You can even choose if you want to vectorize the property names. So in that case, we would have a weapon, name Excalibur, type sword, range short, if you want to. But it's all about creating a semantically findable piece of text, pretty much, so that users can find it. And the BERT model that we use is using 384 dimensions. All right. Let's take a look. So, yes, this is the scene. It's almost like you're looking at the movie itself, right? So now we have Trinity being like, this is not a good idea. Neo is like, yeah, it's going to be a very nice movie scene if we do this, so we should really do it. And I'm glad they did it. So now maybe a little bit of a weird question. Does somebody have a favorite weapon? Oh yeah. Didn't hesitate. A what? Okay. A file. Like this? Well, it's an ACR. I don't have a file in my data set. It's close enough. That's what I want to hear. Because if you look at the distances, it's actually pretty far. So it's at 0.8, and typically, well, I basically cut off everything that is over distance 0.9. I'll just don't show it. So if you are close to 0.9, then you are pretty far away, actually. If we look at, for example, the weapons, it's a very interesting. It's a very small data set, and pretty simple, I would say. So then we could search, for example, a Japanese weapon, and then we get an Odachi, which is indeed a Japanese weapon. And not only because it sounds Japanese, it actually came from Japan. But what's really, so as you can see, you don't really have to do exact search, exact keyword search. You can just put something in, and you'll get something out. Vector databases are really good at giving you a result. What's good to know, though, is that given an input, the result you'll get is always going to be the same, but you never know what that result is going to be, which to me makes vector databases beautiful. It's like gambling with your data set. But I can understand, it's not for everyone. But so given an input, you can never be sure what you're going to get out of the database, and that's really important to understand. For example, we can do something explosive. which is an RPG, which is actually very explosive. So that's pretty good. And yeah, so you can see the distances here are much closer to what we would expect. So last one, anybody favorite weapon? Yeah? Sorry? A Car 98. Wait, that is from Battlefield. Right? Well, and other things. Well, I don't have the Car 98 in my data set, but a Carabiner 98K, wait, that is actually the one, right? But yes, I don't have a model for every weapon in my data set, just throwing that out. Okay. Here. All right. Does anybody play Dungeons and Dragons here? A couple people, nice. If you can't resonate with Dungeons and Dragons, you can substitute everything D&D related with Harry Potter. It's pretty much the same. So we have a wizard, which is a little bit forgetful, and doesn't really remember which spells he can use. So we're going to help him. He's going to be ambushed by a thug, and we're going to search through imported database of all Dungeons and Dragons spells to find spells that we can use to defeat the thug. Yes, fire. Now this dataset is a little bit more complex than the weapons, right? So it's a lot of text, it's a lot of things. I downloaded it from kaggle.com, amazing website, a lot of open source datasets if you want to play with these things yourself. But what's really important here is that CSV is really set up to be machine readable, right? So you have the properties, the headers, and the machine can read it quite easily, and then you can use it to do whatever you want. But actually, datasets like that are pretty horrible to put in a vector database because you want human readable things. You want things that make semantically a lot of sense. So what I had to do here to make it searchable, I created a description that is very semantic or very natural language. So I create, okay, this is the name, this spells can be casted by these classes, this is the level, this is the semantic components, the material cost is this, or there is no material cost, stuff like that. And what you can do, for example, is you can say, hey, I don't want you to vectorize any of these properties in this vector space. I want you only to vectorize the name and the description of this object, and that is what I did here. But the rest of the properties are still going to be saved in the database. So you actually only query against the name and the description of the spell, but once you get the object, you actually get all the properties out of the database that you use, that your machine can easily parse and use it for whatever you want to use it, right? All right. Here. So yeah, I don't know if anybody has played Baldur's Gate 3. Pretty popular game. It's almost like you're looking at the clone, I know. Yeah, so what should we blow up this thug with? A meteor strike. So let's see what we get. So we get Melf's minute meteors, Storm of Vengeance, a meteor swarm, which is, you know, pretty close, I would say. The keywords are there. And then if we cast one, death. All right. Anything else? Yeah? Carsus you write with a K, right? I want Carsus's avatar. Let's see. Alter self and major image. No, it's not what we're searching for, right? Well, you know, we're getting pretty close. So what you see here, because you have a lot of text, a lot of things you are vectorizing, the more text the user is putting in their prompt, the worse your result is going to be, because all the text is actually going to be vectorized. So they do some checks like removing adjectives and stuff like that, but if I would type in, okay, I really need a spell that is something like this, and then I want to do this, and then something like this, then what you're going to get out is going to be probably not what you're searching for, because there's a lot of noise vectorized with the actual prompt. We can do, for example, I need a fireball or something. So let's see what we get. We have, well, all three have to do something with fire, so that's nice. And of course, the fireball itself. Yeah. Sorry? Anything that anybody wants to try out? I mean, you can even try to break my demo if you dare. You could go as far as I need a spell that makes them sleep. And then dream, druid grove, and sleep. So we are killing them with laziness. And then, well, the particle effect is always the same, but we'll get to that in a bit. All right. Now, so we've seen that you can put in a lot of text, and you can actually quite easily get text out of the database. But you know, it's not a silver bullet. There's a big chance your data set needs to be a little bit, you know, altered, made semantically searchable, so to say. Has anybody played this game? It's such a weird game. All you do, you're on Rails, and you are taking pictures of Pokemon and throwing apples at them, right? If I remember correctly, that's basically it. So weird, but it was very popular, or it is very popular. So we're gonna recreate it, of course. So we have Ash that will be walking around. He really likes to flip his hat when he sees Pokemon, and then we'll be taking a picture of the Pokemon we see. And then we're going to do vectorize that image and through a ResNet 50 embedding model and supplying the image to the vector database, and hopefully we can find the Pokemon we're looking at. If you look at the data set, here we have a CSV with all the Pokemon names out there, or I don't know how many Pokemon there are out there, but I have 721. But I assume there are more right now. Spoiler alert, this is the one. Okay. And this is the icon, the image of the Pokemon that I have put in the database. And I have all, for those 721, an icon. So here another one, here another one. Who is this Pokemon? Oh, okay. Are you a Pokemon expert? How about, what is number 25? Pikachu. Oh, that is very true. How about number 50? No? That's a Diglett? Yeah. But I've experienced it. The highest we've got was to 200 something. They could name every single number. Oh, this is unknown. That one I know. No. All right. Enough puns. All right. So. All right. Yes, this is at Sketchum. Totally. We were walking around. Which is this Pokemon? If we take an image, indeed, you can see we found Pikachu. So what it does, it takes an image of the camera frustum, what the camera is seeing in Unity, base64 encodes it, sends it to the database, checks it against what I've already in there, and as you can see, you can find Pikachu. But that's a very popular one. Let's go to a little bit less popular. Which one is this? I'm afraid it's B#. Vector databases don't lie. So if I if I look from here, no, now it's Primplup. How about no, it's Gallade. So as you can see, there is a little bit of error margin, you could say. Where am I? So and maybe another popular one. This is and. No, it's Argen? What the hell is that? So, as you can see, it doesn't really find Pokemon. Well, Pikachu worked quite well, but the rest. So here, what you see here is what the camera sees that I sent. So it has a very beautiful yellow backdrop. I'll just go ahead and say it. It's Pikachu yellow. Because unfortunately, vector databases, or the ResNet 50 model I use, doesn't really understand Pokemon. So the context of, okay, this is a Pokemon, it doesn't really understand it. And if you look, also if you look at the images that I use, for the hell, it's very, cartoon, flat, with a white background. Then you could say, okay, why don't you use a transparent background? That's not possible because the embedding model will fill any transparent pixels with white or black. So you have to choose between white or black. And then when it doesn't really understand the context of the image, okay, what is this context? What am I seeing here actually? It will default to shapes, colors, and stuff like that. So the earlier versions could find white Pokemon very well, but Pokemon like Pikachu that are very yellow and stuff like that, they couldn't find it at all. Now, what could you do to make this better? Well, for starters, I could spend a couple million training a model on Pokemon images to, have a Pokemon Finder model with the risk of being sued by Nintendo. I didn't want to risk that. So another thing you could do, for example, is I could take multiple angle pictures of the 3D models I use and put those in the database, and then also use more different type of icons or pictures of the Pokemon, so not only one with one aspect to it. Then you could probably find better results. That said, I thought it was quite important to show that you don't expect to just put your images in a vector database and always match it, especially when the context of the image is quite, let's say, niche or unique or not easily understandable by embedding model. All right. Our wizard is very forgetful, so he basically went right again and came back to the same bridge. This time we're going to make things a little bit more gamey. So once we do a query for a spell, and it will find something, we're going to grab the name of the spell and query against an icon database or vector space in the vector database. And hopefully like that we can find an icon that is very similar to the name of the spell we are searching for. And like that we can make things a little bit more gamey, a bit more fun, right? And this is done using a so-called clip model. It's by OpenAI, and the clip model is a multimodal model, which can actually embed images and text in the same vector space. So that means using a clip model, you can search images using text, or search text using images, or everything in between. If you look at the icons, these are the icons. So this is, for example, one of them. They're all 256 times 256. Their quality is pretty good. They're not labeled whatsoever. No pre-processing was done, no labeling, whatever. Just icon with the number of the icon, and like that in the database. And just let the embedding model do its work. I bought these icons 10 years ago of a Humble Bundle, which is like a thing you can buy cheap packs from if you're into game development. Back then, my mother said, "You're wasting your money." Well, who is wasting their money now? All right. So here we have our very forgetful wizard again. I have a thing where whenever I give a presentation, I really need to show an explosion, so I'll start with that. So we're searching for a fireball. And as you can see, I mean, you could argue that this is indeed an icon of a fireball, right? Or pyrotechnics, or a firebolt. So as you can see, it's pretty accurate, pretty good. And again, there was no labeling of whatever done on the icon. It was just understood the context. Okay, this has something to do with fire. And then if we cast it, you can see an explosion. And let's put him back where he was for the eternal torment he's about to suffer. Anything else you guys want to see? A tank. I'm really curious what we're going to see now. Create or destroy water, a stinking cloud, or pyrotechnics. I guess pyrotechnics is pretty close. But yeah, tank is not really a spell in Dungeons and Dragons world. Well, at least not yet. But if we cast, for example, stinking cloud, let's see. You can see there was a different particle effect. So we leveled up. We can do, for example, lightning. And I know there is a typo, but it doesn't really matter. Well, in this case, a little bit. But but overall, you can use typos, and you most of the time you'll get a little bit what you're searching for. And then we can killing with light. There we go. Or how about a poison cloud? Let's see what we get. Oh, again, stinky cloud, incendiary cloud, and then let's see. So yeah, so now what's happened? Well, I mean, I've got a little bit nerd out here. If you have icons, what I do is I extract the average color of the icon, and then if it's a dominantly red icon, I use a fireball. If it's dominantly blue, I use lightning. If it's dominantly yellow, I use other particle effect. I like that you can have multiple particle effects without creating a particle effect for every single of the 500 icons I have in the database. So last one, poison. Well, let's kill him by protecting them for poison. And then you can see ejected. You know. All right. Yeah, we're almost done. I'm a huge metalhead. Really love heavy metal music. Does anybody recognize this? And what is it? Sorry? Brutal, yeah. So this is from the Metalocalypse. It's the best heavy metal cartoon out there. And they have a song called the Duncan Hills Coffee Jingle, which to me is the international coffee anthem. And since we're developers, we really like coffee, right? In the database, I've put a lot of songs with the lyrics from all kinds of artists. I have Beyoncé, I have Billie Eilish, Coldplay, Lady Gaga, Post Malone, Taylor Swift, super metal, I guess. And I have 3 metal songs. I have one by Metallica, one by Dragon Force, Through the Fire and Flames, and Death Clock, Duncan Hill's Coffee Jingle. And that is the song we'll be searching for, because one problem I've been having my whole life is when I hear a metal song and the grunting, you can't really understand the grunting, right? So I was like, okay, I can make. How difficult can it be to make a Shazam for grunting? So that is what I try to do. So what we're gonna do is using an embedding model will be transcribing the song that is gonna play. On your left side, you'll see the transcribed lyrics, so what the model thinks is being said. On your right side, you'll see the actual lyrics, so what the song is actually saying. And every 500 milliseconds, we'll be querying our lyric database to see if we can find the song using the transcribed lyrics and the artist that we're searching for. So, who thinks we'll find the song? A lot of doubters here. Who thinks no way? Okay, who thinks it depends, like a good software engineer? All right. Okay, so it's transcribing the song right now. It takes a little bit, and then it's going to start. Beyoncé, not very exactly what we searched. Post Malone, there we have it for a bit. Taylor Swift. Fetish, Lady Gaga. Ed Sheeran. Coldplay. Another metal song, pretty good. Billie Eilish again. Coldplay. Again Beyoncé. What's really funny is that the guitar solo is Ed Sheeran. It's always like that. So I don't know what happens there. Maybe his voice is just so high pitched that it thinks that it's a guitar solo. And as you can see, we had a maybe 1 second that we actually found our song, and most of the time we had no idea what was being said. And to that, because we're over time, I have to say, when Skynet comes and rises and starts to take over, if we just start to grunt against each other, they will have no idea what we're saying. It's gonna be easy one.